we'll do derivation for the equation for principle of impulse and momentum. Then this Wednesday, we will cover the other two. Okay. Now, why we need to learn about the impulse and momentum? One of the application is because of the impulse, like when you have a cargo ship, something big like this, you cannot, there's no brake in the ship like this. So you need to, as a captain, you need to know when to slow down the engine. And then sometimes you use the tugboat to push the boat to a certain direction. Okay, so they are applying on the principle of impulse and momentum, right? Okay, now we start to go into three-dimensional linear angular momentum. Previously, when we learn about particles, we know that L, or linear momentum, equal to mv, momentum equal to mass multiplied by velocity. So when we look at rigid body, we break rigid body into many particles, many small components. So our linear momentum equal to the sum of all the individual components. Okay. And for rigid body, we focus on what actually happened to the center of gravity. So we will take free body diagram on the left equal to kinetic diagram on the right. So all the moment, all the mass multiplied by the small individual velocity on the free body diagram will equal to the mass multiplied by the what happened to the center of mass. Okay. Okay. So just to summarize, what is this chapter about? Is to focus on center of gravity. You just need to focus on the center of gravity, the velocity at the center of gravity. Okay, so this one you are quite familiar every time you see this kind of diagram. So you have velocity, you have point P, and so and so. So velocity we can derive into vector form. And again, we are not interested in derivation. If we have time, we go and see how we derive the equation. What we want to know is application of this one. You can see this one ijk means in the vector form. At the end, we arrive at this form, angular momentum. Anyway, I'll just at the end, from the lengthy equation, our angular momentum h equal to I omega. So angular momentum h at P will equal to I P omega. Okay, and because of this P is away from G, what you need to do is to transform this I. Look this I as IO equal to IG plus MD square. Okay, the rest is just substitution. So today our only equation is this one. Angular momentum equal to I omega. So if it's at the center of gravity or center of mass, it will be IG omega. Okay, this one, IO equal to IG plus MD square. Sometimes the question will give you hints that you need to use this one by you're seeing this parallel axis theorem. This one you learn in statics. But in this module, you don't need to calculate the central everything. In this module, you only need to refer to the appendix, the table form. Okay. Yeah. So if you compare IO equal to IG plus MD square with this equation, this x squared plus y squared actually is the distance of G to P. This is the D. Okay, in the Cartesian plane is x squared plus y squared. You get the D. So basically, it's still this concept. Okay, nothing complex. So it looks very complex, but at the end, still derivation. At the end, we arrive at one simple equation. The rest, if you're interested, you can read. Okay. So our HP, you can take, just now we have these two. So if you have, let me go back. You have, so this one is a complete equation. If it's not at the G, all right. But again, you just need to remember H equal to IW. If you have translation, means you omega 0, then you only need to consider the velocity and the mass. mv is momentum. Momentum you multiply by the y is moment of momentum. Right. What I want to say here is okay. So your HP or your H, you have two components. If it's you have a translation, means in the move in the straight line, you need to consider d multiplied by the mv, means this is the moment of angular moment of momentum. Means you take momentum multiplied by the perpendicular distance, you get a moment of momentum. Okay, so for example, this one, how you get moment? How you get momentum? M multiplied by V at the center of centroid or mass, mv, and then when you extend this one with the reference point A with the perpendicular distance, you can get moment. Moment is F multiplied D, right? But in this case, we take a moment of momentum, so mv multiplied D, you get translation momentum, right? All right. So this is when you have a translation, you only need to consider mv multiplied by the perpendicular distance. Okay. When you have a rotation, this one rotation means there is no movement, there is no straight line left, right, but this one rotate in the circular motion. Then you will have this equation. So this is translation. So if you have a rotation, your H will become Ig omega plus Rg m and Vg. Okay. Or you will arrive at the form of Ig plus m r square omega. Why? How you get omega? V equal to omega r. So you substitute this one with omega r, you get double r square. Right? So if you again you look at this form, Ig plus mr square, it actually is Ig plus md square. We still arrive at H equal to IW. Okay. So when you have a rotation with a momentum at the center of gravity. When you have rotation plus this vector, then the complete equation will be the translation plus rotation at the same time. Okay. So this is a rotation component. This will be it convert into rotation. Convert into rotation. Okay. So this is there are two types. One is translation, one is rotation. So both are different approach. One is in terms of omega, one is in mv multiplied by d. Okay. Then I'll show you in a tutorial question. General plane is combined two. Then at the end, you have this very lengthy equation. General plane means you have these two. You combine the two, you'll get dmb plus I omega. Okay, so this I depends on the focus point. If it's away from the center of gravity, then you need to apply this one, mg plus md squared, or you calculate the r, right? The distance from the one point to the center of gravity. So you cut here. So this is a general plane equation. How you know whether it's general plane or rotation? Rotation, when there's always have a fixed point that cannot move left, right. And this one only rotate. Okay. General plane, there's no fixture, there's no reaction, there's no connector. And this one able to move left, right, and rotate. That's a difference. Okay. So, or in short, you can memorize this one, H equal to dmb plus I omega. It depends on the question. If the question don't have rotation, then you remove this one. You only see dmb. If the question only have rotation, you close the translation part, then you only have I omega. Okay, so these are the things. Again, I won't ask you the derivation. I will only ask you to apply the equation. Okay, so general plane, something like this, it rotates somewhere, so and so. Okay, so if you have things that center of gravity and the center of point that is moving, then there is a combination of general plane. Yeah, so this question is not asking you about this. This question asks you about this arm. So this arm is free to move in this direction. Okay, so it's the same. So let's look at this example. So you have a rod there, and point A is moving down straight with a 2 meter per second. And there's a starting angle of 30 degrees at B. And you are given the center of mass at the center. So from here, you are more interested in applying H equal to dmb if there is a translation, I omega if there is a rotation. So given instant, you're given a mass of that things. So determine the angular momentum about point G here. Means this one will rotate this way. And about IC, instantaneous location. So instantaneous location is you draw the arrow of V, right? This one will slide here. This one also will slide to the left, right? So IC, how to draw IC? You put the arrow over here, arrow point down, then the tail, you use your ruler, draw one line to the left or to the right also can. Then B is to the left. So you put your ruler there, either you draw up or draw down. So there will be an intersection point between A and B. So there will be one intersection point. This one you can find by trigonometry, right? So this one go to the point B will move to the left. If you use your ruler, the angle will be 90 degrees, right? If you draw A, go down. If you put your ruler, you draw a line to the left, also 90 degrees. So basically you're forming a triangular here. So you can find with the 4 meter, with the angle 30 degree, you're able to find the length of this one, the length of this one. Okay. So we established the IC point because from IC, you know how to find omega. All right. So let's say I have a rod, 2 point, and if I have an IC point, this is your IC. This one will turn left or right, clockwise or anti-clockwise. This will be omega. This omega shared by this center of gravity, center of mass there. Okay. So this is how we going to do IC method. You draw point A, point B, then put in the arrow of the 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 velocity. IC only we use velocity. We only focus on velocity. Then you join the two things together. Of course, if you really want to draw IC, my A velocity here I should put down here. I should put my 2 meter per second over here, not at the top. Okay, then I use my ruler, draw to the left. My VB, draw up. Okay. Okay. We are more interested to find the R here and the velocity here. So you draw the IC, you have all the angle. So you can copy the 30 degree here and there. Right? 30 degree here, 30 degree here, and 30 degree here. Okay, maybe VG, okay, VG, when you connect dot to IC, they always 90 degree to the arrow, to the velocity. So that's why we can mark 90 degree here, and the angle over here is 30 degree. Okay. Then you mark B, you mark G, then the distance, BG is 2 meter, AG is 2 meter. You can calculate, you can calculate. So this is 4. So you know that you can, okay, this is 4. Then this point A to IC is 4 meter cos 30. And you know that from, if you're standing here, you view the velocity this way and this way. So you're actually seeing the thing swinging anti-clockwise. So draw the arrow of how it swing. This is the omega. Okay. Now you know that V equal to omega R. You want to find the omega. You have the V, you have the R. Okay. This V and R must be, this V and R, V and R must be 90 degree. This V and R, this is the R, this is the V must 90 degree. You can use here and here, you can use here and here. But you know that one confirmed value is A, so you use A. So A divided by 4 cos 30, you get your omega. So chapter 7, chapter 8, or chapter 6, 7, 8, the first thing in the question is to find omega, no matter how. Once you find omega, you will solve for lots of things. Okay? So remember, V equal to omega R is a very important equation. Okay? Okay, then you substitute back. Once you have omega, you can write V equal to omega R. So you take omega multiplied by the R. So velocity of G will be this value. Omega is this omega multiplied by the R. You will get, again, the value is radian per second for angular velocity. So at the end, you find what is happening to the center of mass velocity there, 1 point something. Okay. So far, everything makes sense to you. Yeah. Okay. So again, first thing is to draw the free body diagram, complete the IC point, because IC is a quick way to find the omega. Then use V equal to omega R to play around, see what is missing. And again, for chapter 8, we focus 6, 7, 8, we focus on what happening to the center of gravities. Chapter 6, F equal to ma, we focus on center of mass, but in acceleration. Chapter 7, 7, 8, we look at velocity. Okay. Okay, so in this case, center of gravity is omega, is turning in omega, right? So if you stand at here, the G actually is turning in the turning, so we only have IG. So how to find IG? You go to the table. This is a rod at the center of the rod. You either read IXX or IYY, depends on the table. You'll get 1/12 ml square. You need to refer to the table. Then omega is from your answer. You press calculator, you get your angular momentum. Angular momentum is in the term, the unit will be kilogram meter square over second. It will be in kilogram meter square over second. And in this direction is anti-clockwise direction. Of course, you don't need to write the arrow because in the front here, you already write the equation. You already write the direction. Omega is angular velocity. You from IC. IC, this omega share with this model. This omega same. This omega same as all the point here. Here, here, here. Why? Because V equal to omega R. Okay? The omega value is the same for all the point. When you have V and R, it must be VA with IC stroke A. It must be this pair. It cannot take VB with another R. Cannot. It must come with the pair. VG must come with the RIC with G, and then VB with maybe RICB. Okay, it must come with this pair, omega. R and V must one pair. This R and V must one pair. R and V must be one pair, 90 degree. You cannot simply take one point and then this, if you put here, then you'll need to have the R and the V here. Okay, it comes with 1 point, one pair, cannot jump the sequence. However, the main point here is omega. It must always same on the point on the object. Okay, so once you have that one, so once you have the rotation angular momentum. So if you look at IC, IC is a combination of translation plus rotation. Right. So this one actually is what already calculated just now. This is what you calculated just now. The H at here, H equal to IG plus omega. But if you shift your angular momentum from G point to IC, you actually need to calculate the IO equal to mg plus md square in your equation here. Or you can memorize the full one here lah. Okay, you put in I omega. This one is the just now you already calculate plus mvd. Mvd is this one, mvg plus the distance here. So at IC is 15 point something kilogram meter square per second. At center of gravity, the angular momentum is 3 point something. Okay. So still, angular momentum equal to I omega. It depends on where you see the point. Okay, if you're at G, then there's no md square. If you're looking at one of the point away from G, then you need to apply Ig equal to md square in this equation. Okay. This is another solution. You arrive at the same answer where you apply this one. IO equal to Ig plus md square or mr square. Same, both are same. But I will just recommend you memorize this one. Okay. Okay. If you know how to calculate angular momentum, then we combine impulse already. Okay. Principle of impulse. We derive the equation F equal to ma at center of mass. So A equal to dv dt. Pull the dt to the left hand side. F multiplied by time, it gives you an impulse. And then you integrate it. Okay, you integrate it. You arrive at this equation. So you move your dt to the left. You integrate left hand side, integrate right hand side. You get this equation. In fact, you already see this equation previously in the particles. It's just a particle, you don't focus on center of gravity. Right? There's only one dot always. So if you see principle of impulse and momentum, basically it's momentum before plus the impulse equal to the momentum after. Or the impulse equal to the differences of momentum. Okay. So because this is a rigid body, so remember, rigid body, you always link V equal to omega R. You need to change this V into omega. Okay. So the rest is like this lah. So this is just a combination of what happening to the principle of impulse and momentum. mv1 means the momentum at the center of gravity to one direction, plus impulse with the effect of time equal to the momentum there. Okay. Okay. Another one. This is the linear impulse and momentum. This is what you learn. Now we add a little bit, one more term in front called angular impulse. So angular impulse, you need to recall m equal to I alpha. Okay. Then you move alpha equal to omega dt. You move the dt to the left-hand side. You integrate left and right. You arrive at this equation. Okay. M dt, m multiplied by time, you get angular impulse. I omega is angular momentum. I omega is angular momentum. So this is what you learned just now. Angular momentum equal to I omega. This is what you learned just now. Okay. So in short, basically, there are two the same structure, which is moment multiplied by time equal to the changes of angular momentum. Okay, or you can write this one as h2 minus h1. What is h? H is I omega. Okay, and what is the difference between this equation and this equation? One is G, one is O. Means this one, if you see the G mean is focused on the center of mass. If you see O means the interest point is away the center of mass, where you need to apply this equation. IO equal to IG plus MD squared in your calculation. That is the differences. Okay, basically, you already learned the principle previously. Okay. To summarize, principle of angular impulse and momentum, you always apply these three equations. mv plus f time equal to mv. These two is linear momentum, linear impulse and momentum. The first one, linear impulse because these two move in a straight line, x and y direction. This one move in the rotation in the angular momentum, angular dimension. So these three will give you to solve three unknown. This one, this one, this one. Three equations give you solve three unknown. Okay. So this one is h1 plus mt, which is angular impulse, equal to h2. Yeah. The rest you read, The rest you read. Basically, it's just telling you what actually happened there. Okay. The rest you read. Important is the three equation that you see on the screen there. You need to combine linear impulse, the two yellow color, and the white color one is angular impulse and momentum. This one is to find the omega sometimes. All right, omega. Okay, the rest you read. Then we'll show you how to apply. Okay, so this is how we apply. So you are given a mass of the disk. So mass of the disk is given. Remember, every time you see a mass in chapter 6, 7, 8, remember, go and label where is your G point, your center of mass point. Okay, always at the center and then go down because you have a W there. Just in case the question asks you something about the forces. Okay, act upon a constant couple moment 6 Newton meter. It tells you the rotation direction. Force is given. So this one got two, moment and force. So when you see moment and force, actually is asks you to use the linear impulse and momentum, and angular impulse and momentum. Determine angular velocity of the disk 2 seconds after. When you see the question, add some time there, means it linked to the impulse already. If you see the question, angular velocity without time, then it still stay at omega question. Okay, starting from rest. What is the force component reaction at the pin A here? So remember, it asks you the reaction at pin. So A here, you have AX and AY. Okay. So since you need to find angular velocity omega, force, time, so this one is actually, you are applying principle of impulse and momentum. We draw free body diagram. Again, we only apply the three equation, right? The three equation. You draw where is your positive xy, where is the positive direction of omega. This is very important for chapter 8, this axis. When you want to apply the principle of impulse and momentum, always draw this axis first. Right? Where is your x positive, y positive, where is the omega positive? This one, omega positive, will follow the motion so that you get positive in your solution. So once you have that, go to the center of the object, give you the radius, and there's a force go down. Remember, there's a omega W there. When you go into the rigid body chapter 6, 7, 8, remember they also give you the mass. Always go to the free body diagram and draw W. This will be the careless mistakes usually in the final exam, question 4. You will forget this one, the omega, the weight. Okay, then your AX, AY, because the question asks you second part, the force component at reaction pin. So we assume X to the left, Y go up, right? Again, all these are assumption, AX, AY. You can draw to the left, you can draw down, no problem. But you'll get negative, you need to flip back the arrow. Then there is a moment, 6 Newton meter there. So this is your free body diagram. Okay. So this mass at the center do not move. However, loading causes the disk to rotate clockwise. So this is the status of this object. It do not move left, right, up, down, but it will rotate. So, and in this case, everything is at the center of gravity. So later, if you want to apply your angular momentum, H equal to Ig omega, you don't need md square. Straight away refer to table, the circular disk equation. Okay, you refer to circular disk at the center will be half mr square. So you substitute the value there. This is a moment of inertia. Okay, why you need moment inertia? Because m equal to I alpha. Sometimes you need to find the alpha. Okay, I, you have one value there, kilogram meter square. Then you apply these three equations. Principle of impulse momentum. mv plus ft equal to mv. Write this one in x, write this one in y, and focus on one point. In this case, is at the center of the this. In this case, I change this one to A, sub A. If you want to write G also can, but go to your free body diagram and label this one as G. Don't write something that not appeared in your free body diagram. Then suddenly you give me G, I will put a question mark there. Where is G? All right. Pull out these three equations and the angular momentum equation, angular impulse and momentum equation. I omega or H, H1 plus MT equal to H2. So you write I omega 1 plus M dt equal to I omega 2. Okay, write the form, or this form, and then you substitute accordingly. Okay, so for the first one, VA, why A is 0? Because A do not move anywhere. A point do not move, F, X, Y do not move, so 0. Then FT, there is a force there. There's a force there in X direction. When there's a force in X direction multiplied by time, there is an impulse. As long as there's a force in X direction, it will give you impulse. Time is 2 seconds given in the question. So velocity 2 seconds after starting from rest. So 2 seconds. Substitute 2 here in t. Right. So what happened about the VA2? VA2, in this case, we don't know. So you just put VA2 there lah. VA2 VA2 because VA also doesn't move. This point after 2 seconds also doesn't move. So V2 0. So basically first equation do not solve anything. Then we try second equation. M VA1, what do you think? 0 also. Okay. Then AY in Y direction, multiply 2 seconds, you get impulse. In Y direction, W multiply 2 seconds also give you impulse. 50 Newton multiply 2 also give you impulse. Then VA2 also 0 because point A doesn't move anywhere. Okay, so here you have one unknown there. W you know, mg. G used 9.81. So this one you have value. So only one unknown in this equation. You can find AY. Then the second one, IA you define 0.2. IA you are using IG by the table. Circular disc at the center point is either IXX or IYY. Right? You refer to the table. So omega 1 before it start from rest. So although you have 0.2 here, omega 1 is 0. Then MA multiply by time. You are given the moment here. So this moment multiply 2 seconds. Then 50, this one also, right? So 50, yeah. I think something missing in my calculation. It will be 50 multiplied by 0.2. Then this one give you moment. Something missing. 0.2 is missing in my step here. Huh? AY? No, I'm not talking about AY. I talk about this one. This one. This one? This one is force. A is not moving, but this part is here, not here. This one is force. As long as there's a force, multiply by time, you get impulse. Although it doesn't move, but there's a force, multiply time, there is a force. So all the force in Y, W will create impulse, 50 will create impulse, AY will create impulse. So again, something missing in my calculation here. IA is 0.2, omega 2, you don't know, you need to find. So basically, from here, you can find your omega 2. Something missing. This one got typo error here. It should be 50 multiply 0.2 here to get the moment clockwise. Okay, AX, you don't know. So AX is 0. AY, you get 148 moving up. And omega 3, 2.6. Okay. Okay, so this is the solution. Yeah. Try to see these three equations and then you know how to put in the value or not. This will be the free body diagram. You actually extract information from this diagram. Okay. Okay, let's see example 3. Same scenario, but now I add another object below there. You see, it's actually similar. It's a similar this, but now I add one more object pull down. The differences is example 2, I use force. Example 3, I use object with the velocity. So same setup, 6 kilo, previous one is 10. Now it's changed to 6. Attach a cord, warp around with 20 kilogram. This moment inertia is given. So this one, you don't need to calculate the moment inertia. But if you want to calculate also, there is a way, right? There's a way. What is the way? You refer to table lah. You refer to the table. This one is G at the G there. IXX or IYY. Refer to the table. Okay. So then you get this value. If the cylinder is initially moving downward with a speed of 2 meters per second, determine the speed in 3 seconds. So involve time. So they must be equation involved with impulse. Right? So ignore the chord. So free body diagram, you draw free body diagram, same axis, x left positive, go up positive. In this one, you know that it rotates clockwise, so omega clockwise positive. Mark A, copy radius, put in the tension cable, pull down. Basically, it's the same. It's the same as example 2. But remember the mg, W. Then there's a reaction there. Pin A, X, A, Y. Now you have omega B. So your T actually is the omega B. Okay, this is to show the T equal to omega B, equal to WB, not omega B. Okay, and there's a speed VB go down there. Okay, okay, I just add a VB go down positive. So you'll be at here, VB, or you can draw at here. Okay. So there's a force or constant. So we start to solve. You can remove this part if you want. You can remove this part. You get right equal to WB equal to mg. Then you use principle of uniform momentum. Okay. So you eliminate AX, AY from the analysis by using principle of angular impulse and momentum. So you use this one. H1 plus MT equal to H2, or I omega equal to MT equal to I omega. We focus on center of gravity to simplify our calculation, right? So in this case, it's asks you everything from the center of gravity. Okay, so this one is from this is just to calculate the what you're trying to calculate. Okay, so you put in all the value. Okay, so IA it was given in the question. If you want to find also can from table. Omega you don't know. Moment multiply time, so 3 seconds. How to find moment from this free body diagram? If you put your finger here, AX, AY gone, W gone. Only you see T. T multiplied by the radius get moment. Moment multiplied by 3 seconds, you get impulse momentum. Impulse moment here. So T3, 0.2. And then this one was given, IA was 0.4. Omega 2, you don't know. Then you look at the cylinder. Cylinder actually is to find the tension. What is the tension value? Okay. So MB, this is momentum, linear momentum equation. Because this one move in straight line. This one move in straight line. That's why we use linear moment and linear impulse and momentum. So MV is given. In this case, negative, because the velocity, okay, this one we assume go up positive. So we assume go up positive. So T FT 586 FY. I try to think how I get this one. MV2. Oh, okay. This one is referring to cylinder, not this one. Okay. If I see this one, then my FT will be this one, forces go up, positive. WV go down, WV is 5886, right? Correct. W is mg, right? The weight is 6 kilogram, right? Is it correct? Let me check. 6 kilogram. 6 kilogram. Please get 6. The number seems not normal to me. Okay, 6. 600. How come 600? I think there's a decimal place is wrong there. I think it should be 6. It should be 5.86. It should be 5.86, not 5886, because your mass of your this drum is 6 kilogram. So 6 kilogram multiplied by 9.81, you get 58.6, not 5886. So typo error. Okay. So this one is your W, 3 seconds. Then you get negative, positive there. Okay. This one is referring to this cylinder free body diagram. Okay. So there's a typo error here. At the end, you get velocity at B after 3 seconds. Okay, this V is when it start to happen. Okay, then this one is missing. So T, do you know T? We don't know the T. Okay. So we find the omega equal to V equal to omega R. You rearrange VB divided by R. This is VB. VB always tangent, follow the rope, go down, VB 2 meter per second, multiply by the radius 90 degree. Okay, so 2 divided by 0.2, omega is 10 radian per second. So your VB2, omega 2, you don't know, but you can put in omega 2 equal to VB with the same radius. Although you let go after 3 seconds, it was still same radius, but different omega. So V divided by same radius, so you get 5 V2. Okay. So what we're trying to do is to substitute this one. We want to eliminate this W2 in this equation to same as here. Either you eliminate this one or you do this one, same. Okay. So the purpose of having this one is to solve this omega 2 and V2. Then you can solve simultaneous equation. Okay. So once you get that one, you get your, this one means when you solve, solve this one and omega 2. Omega 2. Let's see. Means you already find the omega 2 already. Not omega 2. So you solve simultaneous equation. Okay, solve simultaneous equation. So if you start to maybe you can try substitute T equal to WB, and then you see whether you get this answer. Okay. This is the first solution. Second solution is you're using impulse and momentum diagram. Okay. So this one we already arrived at this one, omega 1, omega 2. Okay, this is a solution 2. Mean this one you are using schematic diagram. Before plus impulse equal to momentum. So system angular momentum, you need to consider I omega 1 plus the impulse. Impulse means all the forces will multiply by the time will create impulse. This one multiply 3 seconds, AX 3 seconds, this one 3 seconds, this one 3 seconds. Then equal to IA omega 2. And you solve in X and Y direction. X direction, Y direction. So this one is H1 plus MT plus H2. So IA omega, IA, this one, IA, mv 2, this one. Okay. So this one, how to get this one? This momentum multiplied by the distance here, you will generate this one. This one. This one is this one. IA omega square, omega 1 is 10. So this is angular momentum. So angular momentum, this one mv multiplied by the perpendicular distance, you get the angular momentum also. Plus the moment at G, you put your hand here, AX, AY, WA gone, you only see WB. So W equal to 85.86 multiply 3 second or 2 second. 2 second or 3, I think it's 3 second. 3 seconds. So something wrong in my solution here. It's not 2, it should be 3. Huh? Typo error here. Not 2, but 3 seconds. Equal to this diagram. Equal to angular momentum of this system. So you have one angular momentum and one angular momentum here. So MBV multiplied by 0.2 plus IA omega 2. Omega 2, you don't know. You write in V equal to omega R. It will equal to 5 VB2. So you solve, you arrive at VB2. So these are the second approach lah, by using this diagram. Yeah, so I give you two approach. Two approach. Okay. So I think we stop here. Tomorrow we go into conservation of momentum. Okay, so what is important for today? I flip you to the slides. Is these three equation, the red color one. Okay, MV equal to MV plus FT equal to MV, XY direction plus one more angular momentum, I omega plus MT equal to I omega 2. So these are the three important equations for today. Okay, Wednesday we will look at conservation of momentum. Okay, sign your attendance.